Hello, everyone. Welcome to Anuta Network's case study, delivering 5G ORAN as a service with low-code automation. I'm, I'm Kiran Sirpa, Head of Marketing with Anuta. Here is the agenda. I will start with the customer requirements and I will share their scale requirements. Then I will introduce our solution, Anuta ATOM. I will walk through how the customer developed a workflow to deliver ORAN as a service. I will then share the business outcomes as well as the lessons learned. Worldwide, there is a clear trend. All the service providers, whether they are large or small, are adopting the public cloud. 5G, IoT, edge computing are the primary catalysts for this transition. These technologies demand rapid service delivery, elastic scale with an economical business model. At the same time, these large organizations are also betting on multi-cloud, and it will be a hybrid cloud deployment for the foreseeable future. Today's case study is for a tier 1 telco provider that is building 5G on AWS cloud. This is a huge initiative. 50 cities, 15,000 sites with 100,000 network elements. They are using all the latest technologies in this greenfield network. All the network functions are cloud native and are ORAN compliant. And there is an urgency to deploy the 5G network due to high demand for bandwidth as well as low latency connectivity for applications such as IoT, virtual reality, and augmented reality. The telco provider identified the following functional requirements to deliver ORAN as a service. The network automation support cell site onboarding, software upgrades, network slice creation, telemetry, and closed loop remediation. As you see on the diagram on the left, some of the components are physical routers, such as the cell site routers, some are virtual, and some are containerized. The edge, regional, as well as national data centers are deployed in the AWS cloud. But the environment is very complex. As many as 13 different vendors are providing the necessary hardware, software, and services. Surely, this approach accelerates innovation, but it presents operational bottlenecks, especially when manual processes are followed. Based on our initial discovery, managing the cell site routers requires at least 12 different steps, spanning all the 13 different vendor applications. In the best case, when all the processes are properly streamlined, it will still take 26 hours per device. Just the onboarding itself consumes 15 hours per device. The customer also identified following architectural requirements. Number one, the automation must be cloud native to take advantage of elasticity and time to market advantages from AWS cloud. Number two, security and control is extremely important. The network automation will have the keys to the entire kingdom. If this software is hacked, it's going to be game over. So features like multi-tenancy, role-based access are crucial to ensure security. Multi-tenancy also improves economies of scale, where the resources are shared among the tenants. Number three, the networks are becoming mission critical. Whether it's your kid's school or your technical presentation, network outage is very costly. Geo-redundancy, high availability are crucial for uptime and customer satisfaction. Number four, previously, the customer relied on best-of-breed tools. They used to have one tool for provisioning, one for monitoring, and yet another tool for incident resolution. Going forward, an integrated solution is mandatory to simplify the operations, provide visibility, and generate analytics. Number five, the solution should have a unified interface to accelerate troubleshooting as well as optimize the overall time of the skilled network architects. Finally, this solution should support low latency and high throughput provisioning for 5G networks. So the solution we proposed is Anuta ATOM. A quick trivia for you. The word Anuta means better than the best in Sanskrit. There is also an island in South Pacific by the name Anuta. So what does Anuta ATOM do? It is based on cloud native architecture. It is massively scalable. We have automated 250,000 devices and it supports multi-tenancy. Atom is an integrated software platform. It offers zero-touch provisioning, workflow automation, compliance management, service orchestration, telemetry collection, and closed-loop remediation. Atom supports 45 different vendors, 150 plus platforms, and it integrates with third-party software such as ServiceNow for ticketing, Infoblox for IPAM, SDN controllers, VNF managers, and OSS BSS layers. First, when you deploy Atom in a network, it discovers the infrastructure. It has zero-touch provisioning to onboard new devices with base configuration. It automates stateless methods of procedure, such as software upgrades and stateful services, such as Layer 2 and Layer 3 VPNs. Atom enforces compliance to ensure the device and service configuration follow the company standards. Atom collects telemetry using SNMP or streaming telemetry. It correlates the events and generates alerts based on thresholds. Finally, the advanced closed-loop automation policies automatically remediate known failures. This diagram maps how the various stages of the device lifecycle can be managed by Atom's individual functional modules. For instance, the workflow module takes care of IPAM and integrations with all the 13 different vendors. Compliance module validates configuration across all the vendor elements. Telemetry collects operational metrics, and closed-loop remediation automatically remediates any violations. Atom has a powerful low-code automation platform. Using BPMN models, network architects can represent any complex method of procedure as a workflow by simply dragging and dropping the libraries onto a canvas. It is very similar to building a Visio diagram. Each of the boxes can perform a variety of tasks, including issuing commands to the switches, executing scripts, invoking external systems through APIs. The workflow is bidirectional, so it can be triggered by operators to execute maintenance operations such as software upgrades, config migrations, RMAs, or it can be triggered based on alerts from external systems, including the network elements. There are many out-of-box workflows as well as libraries that can simplify the creation of any method of procedure. Customers can also reuse their existing Python scripts or Ansible playbooks, and Atom has an extensible reporting framework, and it includes predictive analytics to measure the estimated completion of any workflow. So let's figure out how this workflow solution is applied to our customer deployment. This is the overall workflow of onboarding a cell site. As you see here, as soon as a device such as a Cisco NCS or a Juniper ACX is plugged in, based on the DHCP options, the device will contact the Atom in the AWS cloud. Now, based on the device's serial number, Atom will download the base config to the router, and it will force a reboot. Now that the device is up and running, Atom will have connectivity to the bare metal server. Now, Atom will trigger the server installation. It runs the appropriate scripts for Supermicro or Dell servers to install the BIOS, operating system, patches, etc. Atom will also resolve IP addresses from Infoblox. It then runs through the GitLab pipelines to install the VMware vCenter and ESXi hypervisor. On top of that, Atom installs the Kubernetes and finally the DU elements from Mavenir and Altiostar. Atom also pushes the base configs to these virtual radio elements. All along this process, Atom delivers Slack notifications and updates Jira tickets with the status of each of these workflows. This is a high-level snapshot of the Atom workflow. The workflow can execute in parallel to onboard hundreds of cell sites simultaneously. It includes all the error conditions and rollbacks commands as well. In this deployment, Atom also leverages the AI ops capabilities. As Atom runs thousands of workflows, it collects execution metrics, overall process duration, user input, etc. And based on this data, Atom can predict how long a workflow should take to complete. Now, if any cell site is going to miss the SLAs, Atom can automatically open a ticket in Jira for operators review. Further, Atom can detect outliers, bottlenecks, and using the machine learning algorithms. It can even predict when it is going to run out of resources so the operator can take some preemptive actions. So what were the results after deploying Anuta Atom? Compared to the manual efforts, Atom platform helps finish the entire cell site onboarding within 70 minutes per device. The overall device management now takes 2 hours per device. So compared to earlier, it saves at least 24 hours per device. And when you do this at a scale of 100,000 devices, the cost savings add up significantly. In addition to automating the overall cell site management, Atom's workflow also reports how many workflows are in progress. For example, it can show how long each stage of the workflow is consuming. Further, we can drill into a particular city and see the performance of all the activities for that city. Atom's compliance report shows how many devices are matching the company standards. And for the devices that fail the compliance rules, Atom also gives a breakdown of which rules are violated. And the compliance can be grouped based on the type of the device, vendor, or location. You can also get granular reports at the city or region levels. Here, we show the number of tickets that are automatically resolved in the recent past at the city level. The second chart compares the performance metrics such as average throughput, latency, packet loss, and utilization across various cities. So what were the lessons learned? We learned many in the last 4 months. Since the customer has an aggressive deadline, we created small teams, each team containing the engineers from vendors as well as telco network teams. The teams followed the agile model to develop rapid prototypes. The effort helped identify external dependencies much earlier in the project. But still, integration testing was a huge challenge. The teams documented all the regressions and continued to refine the unit tests. This effort gradually reduced the integration effort in the subsequent phases. Since it's not possible to test all the combinations of the 13 different vendors, our team resorted to scenario-based testing that helped us identify the major issues. One other huge challenge is related to reporting. There are multiple users, operators, architects, management, and senior leadership. And it's not practical to imagine all the requirements for reporting ahead of the time. So the team has made the reports field extensible. So now it is very simple to create custom reports using Atom's framework. Finally, such a massive project requires extensive security control. So role-based access is very critical to enforce in each component of the automation. So in summary, Anuta Atom helps the Tier 1 telco offer ORAN as a service by integrating 13 different vendors with low-code automation. Atom introduced AI ops capabilities to ensure all the sites meets the SLAs for onboarding. It eliminated manual operations and delivered granular reports for complete visibility for this massive scale deployment. As I wrap up this presentation, I would like to highlight that this trend towards cloud native architecture will accelerate simply because it helps the telcos reduce costs, deliver faster, scale as needed while ensuring security and compliance. If you would like to know more about Anuta ATOM, please visit our website anutanetworks.com. It provides complete network lifecycle automation and assurance for multi-vendor, multi-domain networks. Thank you.